Let's look at some examples. So our basic vector space, the dimensions are words, and now what we have to do is we have to figure out what does everything look like in that space. So we have a separate dimension for each word, and of course we can't draw it, but if you imagine that you had a vocabulary of 3 words, and every piece of text that you ever generated consisted of words cat, dog, and lion, and you could not use any of the other words, then we can actually start sketching some documents and queries. Right? So that's our vector space. We have 3 dimensions for our 3 vocabulary terms. And the 3 vocabulary terms are our coordinate vectors, x, y, and z. So now if we have some documents, we have to figure out of a way to project a document, which is a string of words, a sequence of words. How do we project that into that space? So let's say we have document 1, and document 1 has the words cat, cat, cat. So it's about cats. In a vector form, that it would look like that. So it has a frequency 0 for lion, it has frequency 3 for cat, and it has frequency 0 for the word dog. So if I tried to draw it in that space, it would follow. It would fall on point 3 on the y-axis, right? All natural, all obvious. Hopefully, very, very boring. If I have document 2 has the words cat and lion, so the vector representation is 0, 1, 1, and it falls into that blue point D2 in the vector space. Now I get document 3. Document 3 is lion, cat, right? So string-wise and order-wise, it's very different from document 2, but because we're doing the bag of words thing, we're blatantly ignoring the order in which the words come in. So documents 2 and document 3 will actually end up being projected to exactly the same point. So as far as the vector space model is concerned, there is no difference between D2 and D3. The order of the words is entirely irrelevant. D4, cat, cat. So it falls on the same axis as D1, it's just a little bit lower. The frequency is 2 instead of 3. So one interesting thing, though, is they are pointing in the same direction. So if we happened to normalize all our vectors to the same Euclidean length, then D4 would be indistinguishable from D1. They'd be the same point in space. Right now, they're not. Okay. Now the query comes along, and our query is unusually verbose, and the user wants to find cat, cat, lion, dog, dog. Right. So whatever information need they have, they feel best to express it in this way. So in terms of a vector space, the coordinates are 2, 2, 1. So 2 for cats, 2 for dogs, and I guess 1 for lions. So that would look like. So you have 2 along the cat, you have 2 along the dog, and you have 1 along the lion. Okay, so that's how we project the documents and queries into our vector space. And then the next question is, once everything is a point in the vector space, how do we measure similarity? How do we measure distance between those things? And you could do a simple thing. You could just measure Euclidean distance, or what's done a lot more often in text, and we'll talk about why, is you could look at the angle between the vectors. So if I want to measure the distance between the query and, say, D2, what I do is, instead of measuring just the Euclidean distance between the 2 points, I take the vectors and I try to measure the angle, or the cosine of the angle between the 2 vectors. So just as a forewarning, we're not actually going to be talking about distances. Most of the time, we need to talk about similarities. So distance and similarity, they're inversely proportional. So if you think distances in your head, just invert everything or take 1 minus everything, and it'll work out.